In this video, we'll show how to set up an integral to find the force exerted by the liquid on a vertical plate. In this case, we have a circle of diameter 3. So let's draw a picture, and it's filled with water. So let's introduce the coordinate system. It's going to be one-dimensional system. X-axis will be pointing down, starting at the top of the cylinder. So the boundaries for this plate will be from 0 all the way to 3, because 3 is the diameter of this circle. Now, to set up an integral, we are going to pick some value x between 0 and 3, and we're going to consider a thin strip with height dx, and now we're going to set up an integral by finding the force exerted by the liquid on this strip first. So it's going to be the pressure times the area, and the pressure is rho g times the depth, and since we choose the origin to be at the level of liquid, the depth here is x, and the area of the strip is dx times the width. So now we're going to spend some time finding the width wx, and it is pretty clear that as x changes, this width also changes. So let's take this picture outside of that context and let's solve this problem geometrically. So we have a circle, we have unknown width, and we also know this distance. So this distance can be computed by looking at the distance between the coordinate of the center, which is at 3/2, and x. So this distance will be this distance right here is x minus 3/2. This distance right here is half of w, and this distance right here is the radius, which is 3/2. So the relation between x and w can be expressed by this formula. And we can solve this formula for w. So it's going to be equal to 2 square root of 3/2 squared minus x minus 3/2 squared. So this is our desired width as a function of w. So it goes right here. I'm going to write 2 square root 3/2 squared minus x minus 3/2 squared, and this is the force exerted on that one strip. So the total force will be equal to the integral from 0 to 3. So the answer to the question is right here. So this integral is the integral that finds the total force exerted on one end of the tank.